Right, number 5, the last task for D2 is to talk about serial dilution and colony counts. So here's a little explanation. We're going to start off with our culture. There's our flask with some cells in, and we don't know how many cells are in there. So the question is, how many cells? So what we could do is we could put a sample like you did and make a plate and see how many colonies form. And there's a slight problem with that. So if we just took out a sample and put it onto a colony, put it onto an agar plate, we might get some cells that grow, but after a while each one of these keeps growing until eventually it just looks like a big mess and you can't count separate colonies. Or another situation might be that we just get a couple of colonies form and these get bigger and bigger over time. But that's not a very good count, is 2. You need to have more counts for it to be statistically viable, so you can use some maths on it. So what we want really is a count that gives just a few colonies, so there's enough to count reliably and you can still see them as separate colonies. So that's the best sort of count. But our culture might have this one where there's too many cells, this one where there's too few, or it might be perfect. So what we need to do is set up some dilutions of this culture so that we can get this plate. So we don't know how diluted we need to make it. Do we need to dilute it by half? Dilute it by 10 times? Who knows? So what we do is we take a sample out of here. So we're going to remove, say, a 1 cm cubed sample. And we put that into a tube that contains 9 cm cubed of medium. Okay, so our 1 cm cubed goes in there. But even then, if we plated that onto our agar, probably that's still not going to be dilute. It's still going to give you a jumbled mix of bacteria. So what we do is we set up some more tubes each with 9 of medium in. So 9 cm cubed medium. So no cells. 9 cm cubed of medium. 9 cm cubed medium. Okay. And then what we do is this first sample, which was if we got 1 of culture and 9 of medium, that is like a 10th dilution. Then we mix that up, and then so we mix and then put that into the next one. So mix, then put that into the next one. So that one goes 1 cm cubed. So 1 cm cubed. And then we mix that, do the same thing, put that in there. So 1 cm cubed after mixing. So that goes in there. And then we do the same thing again there, 1 cm cubed after mixing it. And that goes in there. And so each time we're doing a kind of 1 in 10 dilution. So this one is actually 1 in 100. This one is 1 in 1,000. And then this one is 1 in 10,000. And you can actually keep going with some more tubes. When you make the plates for these, so what you're going to do to make these plates, you take perhaps, say 1 cm cubed each time. And hopefully one of these plates looks like our plate that's easy to count. But we don't know which one it's going to be. Might be right down here, might be right down there. Who knows which one it's going to be. And so, for example, this one might still be having merged colonies that it's hard to count. So too many to count. This one might just have a couple, whereas this one might be just perfect. So you can count them easily. But then what you need to do is, you might think now, okay, I've got, for this one, how many colonies have I got? 1, 2, 3, 4, so I'm going to count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So counted 12 on that one, 2 on that one, too many, and too many. So not going to use that one, not going to use that one, not going to use this one, but I am going to use this one. And the maths that I need to do is, I've got my 12, but I've got this 1,000 dilution that I need to take care of now. So it's going to be times by 1,000 equals 12,000 cells per cm cubed. And that's going to be my final answer. So your written method is just to summarize this and say why we need to do it. So your diagram might be on a separate sheet, or you can fill it on here. So we've got grow culture. We're going to remove 1 cm cubed our sample. So let's just put some numbers on here. So 1 is grow the culture, 2 is remove the 1 cm cubed sample, 3 is add to 9 cm cubed of sterile medium. Then we need to, so that was 3 there, so this one will be 4, so 4 mix. Number 5 is add 1 cm cubed of this mixture to a new tube, which is 9 cm cubed sterile medium. And then we've got another repeat 4 and 5 So this one is repeat 4 and 5 for however many for, and say another 3 dilutions for at least 4 dilutions. Quite often they do one. So we've got our original culture, and then we've got 4 dilutions of it. Then we are, so step 6 will be to remove 1 cm cubed out of each culture. So step 6, remove 1 cm cubed from each mixture. And essentially what you're doing is making a lawn plate from those, but you don't know how many you're going to grow. So 7, add 2, or sometimes they mix it in with the agar. So add 2 sterile Petri dishes with nutrient agar. 8 will be leave it in the right conditions to grow. So 8, incubate at optimum conditions. So for example, it might be 25 degrees C for 48 hours. 9 is do your counts. So count colonies. Count the best plate, which is anything sort of between 20 to say 80 colonies. Don't count if too many or too few. And then the last step is step 10, which is multiply by the dilution factor to get cells per cm cubed. Why do they do this? We just need to explain these too many and too few counts. So they, now let's describe this. If we, if try to count the original culture, then too many to count. These colonies will all be merged in together. So colonies will be merged together. This would lead to an underestimate of your count. So you won't be, your number won't be high enough. So this leads to an underestimate of the count. And then likewise at the other end, if try to count if too diluted, then the numbers will be not accurate, because you might get 2 on this one and 4 on the next one and so on. Then numbers are not accurate and reliable. So overall, we do this dilution series because we don't know how diluted it needs to be for the perfect count. So do the dilution series to find the perfect dilution for accurate counting. And that's D2.